Hi folks, Mr. Long here with our fourth video on the analysis of tables of graphs and graphs with calculus to get you ready for your AP exam. So we're working with the same graph again, over and over again to get used to it. Again, how do I start these questions? Just sort of a reminder. Well, I would be saying that f is being defined as the integral of g. G is the given graph from 5 all the way to whatever x value you want to figure out the value of f at. What does that mean? If I take the derivative of f and then I take the derivative of this side, so the derivative of f is f prime. What's the derivative of an integral? Well, it just gets rid of it. So it's g. So if I read the y values off this graph, it's the slope of f. It's the slope of f. Okay. So and then this integral here. So let's we're going to look at some geometry here in this question and see how it relates. You're going to remember back to transformations and things from grade 11 and advanced functions. The first one that we're going to do here is we're going to do the integral from 9 to 7 of 2g of x plus 10. Well, I don't know. The 2 just means multiply, right? That's an easy one. It's outside the function. So what I would do if it were up to me, I would always reverse the 9 and the 7 to go 7 to 9 because I like reading left to right instead of right to left. And so that makes it a negative out front. But I take the 2 and I plunk it outside as well. So it's 2 multiples of that area. Okay, in this case, negative 2 multiples of this area. And then I would separate out the integral and I would integrate 10 separately. So you're just integrating y equals 10, right? It's the area underneath the graph y equals 10 between 9 and 7, right? So again, we have to switch from 7 to 9, so that makes the plus, and this plus here becomes a negative. Okay, so that's easy. That's going to be 20 because it's, you think of y equals 10 and it's 2 wide. You've got a rectangle 2 wide and 10 tall. It's 20. Okay, but we'll do it with proper integration. So the first question, negative 2, and then I have to get the area from 7 to 9. Well, if I go up to here and I look at this, the area from 7, which is right here, okay, 7's right here, 9 is right here. Again, I know that area is 3.5. That area there is 1.8. So negative 1.8 plus 3.5. Okay, and that works out to 1.7. Right? So this area right here is 1.7. Now that 1.7 has to be multiplied by negative 2, and then I integrate the number 10 to get 10x. It's a minus symbol, and again I go from 7 to 9. So negative 2 times 1.7 is negative 3.4. 10 times 2 is 20, and so it's negative 3.4 minus 20, negative 23.4. Okay, this is just an exercise in mixing algebraic integrals with graphical integrals. Okay, so, and that often, again, you use multiple representations on the AP exam, and the 2 there tends to confuse people. It just means multiply by 2. The next one, however, is a little bit more challenging. So what we're going to do here is I'm just going to quickly draw a graph. So supposing I have this graph here and it looks like this. This is at, say, 6, and this is 0, and this is f at x. What then does f at 2x look like? Remember that made it twice as steep with a trig function. It compressed it horizontally, we say, or there's a scale factor of 2. So what it does is it takes that 6, well, it takes this number and divides it by 2, and it takes that x value and divides by 2. Well, 0 divided by 2 is still 0. 6 divided by 2 is 3. So it has the same y values, so it reaches the same y value way up here, but here it does it in half the width. Hence, it's twice as steep, right? Just like a trig curve. That's how I remember it best. The wheel's revolving twice as fast. If the wheel revolves twice as fast, it revolves around the curve instead of 360 degrees in 180, or instead of 2 pi in 1 pi, right? The x value coordinates get divided by 2. So what does that do to the area? Well, if this area in here was 10, what would this area have to be? Well, the height is the same, right? So the height's the same, it's the width area is just base times height. So this area would have to be 5. Okay, it'd be half as big. So here's what this one says. This one says get the integral of g of 2x between 0 and 1.5. So what we've done is, same sort of thing, we've compressed it by a factor of 2. So what we had, I would always draw this. I'm just going to remove this stuff here. And I don't think there's anything there to remove, but I think what we can do here is recognize that if I'm going from 0 to 1.5 on the new graph, that means I went from 0 to 3 on the original graph, right? Just like here, see where f at x is 0 to 6, f at 2x is 0 to 3. Well, if I'm going from 0 to 1.5 on 2x, that means I'm going from 0 to 3 on g of x. But again, I'm going to have to divide by 2. Okay, makes sense, right? So this right here, if we think of it on here, this graph, I'm just going to take this graph sort of and translate it down. It would mean that this graph would still look like that, except it would only be, so it would have the same shape as this, but it would be half as wide. So if this area is 8, this area is going to be 4. Okay, so 0 to 1.5 on 2x means you're going from 0 to 3 on g of x. And then so you would calculate that, and then you know you need to divide by 2. Okay, so because again, do we have a graph of g at 2x? No, we've got to relate it to g of x. And these are, so the reason they put these sorts of things on, these are to make sure that you understood transformations in grade 11. But I'm pretty sure you can figure these ones out. So we know that this area is 8, so it's just going to be 8 divided by 2, which is 4. Next one. So now we get into some limits. Okay, we get into some limits. So one of the things about limits is one of the limits that we started with. One of the limits we started with was limit as h approaches 0, f at x plus h minus f at x, and that's all divided by h. So we called that the limit of the difference quotient. Okay, so that gave us the derivative, okay, the rate of change of the slope, because this right here was our rise, right? That's the rise, and that's the run. Okay, and we're getting, when h is a number like 5, we've got a secant, but if h is almost 0, we've got a tangent. Okay, so look at this question here. So f at 7 plus p plus 5.5 divided by p as p approaches 0. Now, we've changed the letters from h, right? So does this look sort of like this? Well, yeah, it does. Instead of an x, we've got a 7. Well, could x be 7? So this gives you the slope at any x value, but if I put a number in here, and maybe it becomes 5, and then a 5 would go here for x, that would mean 5 plus h minus f at 5. Well, that would mean getting the tangent slope right at x equals 5. So it's possible that this means get the tangent slope of f at 7. But we've got to do a bit more work to make sure it's right. So what can we do? So the first thing we want to do is just remember that it looks like this, right? F at x plus h minus f at x over h, except we've just replaced it with p. But what I need to do is I need to know, what is that 5.5? Let's verify that 5.5. If I've got it right, I would know that it's f at 7 plus p minus f at 7. Okay, minus f at 7. Let's see. So if x equals 7, then what is f at 7? Okay, f at 7, so let's think about that for a second. F at 7 is, there's 7 right there, and it's the area from, so we'd have to do the integral from 5 to 7 of g, and that would equal f at 7. Oh, well, if I go from there to there, it's negative 5.5. The area's under the curve. Look at that. So what this really is then, if I write it out, is it's f at 7 plus p, well, I'll just write it as an h, 7 plus h minus, oh, it's plus 5.5, which is minus negative 5.5 all over h. This right here, limit, is just asking me for the derivative, the tangent slope when x equals 7. How do I get that? Well, all I have to do is to read off, to get f prime at 7, we know that's g at 7. So all I do is I go to x equals 7 out here, go down and read the y value. It's about negative 3.7. Okay, so that's my answer. That's my answer. So again, how did we go about doing that? How do we go about doing that? Well, you look at this and you think, okay, it kind of looks like f at x plus h minus f at x all over h, because I see the 7 plus p. So the 7 could be an x value, x plus p, a specific x value. The p could just be h. The problem I have is, what the heck is that 5.5 about? I know that if it is a difference quotient, it has to be f at x plus p minus f at x. So in this case, f at x would be f at 7. Okay, so I figured out f at 7. Sure enough, f at 7 was negative 5.5, and it worked. Okay, so it just means the derivative of f when x equals negative 3.7, which is just the y value on the graph of g. Okay, here's a limit question. Okay, a limit question. And so here's where we're combining both graphs and algebra. And so it's the limit as x approaches 3 for g of x divided by sine of 2x minus 6. Well, I always have to test and see if a limit is 0 over 0. So I've got g at 3 divided by sine of, and what I did is I replaced 3, x with 3. So 2 times 3 is 6 minus 6. Sine of 0 is 0. Okay, we got that. What is g at 3? So g at 3, I have to go to that right there, and g at 3 is also 0. So I have 0 over 0. So we know that I can cross that out and cross that out, because we can't have a limit worth 0 over 0, even though I used to leave that in, but now I know better. So let's do L'Hopital's rule now. Because I have 0 over 0, that means I can do L'Hopital's rule. What is L'Hopital's rule? Do the derivative of the top, the derivative of the bottom. What is the derivative of g of x? G prime of x. Okay, the limit, or the derivative of g of x is g prime of x. What's g prime of x? The slope. What's the slope when x equals 3? Oops, wrong one. We can do our tangent slope there. That's negative 8. That's 1. So negative 8 over 1 is negative 8. So g prime at 3 is, in fact, negative 8. Then I have to differentiate the bottom. So the derivative of the bottom is going to be, what's the derivative of sine? Cos. That's the outside derivative. What's the inside derivative? 2. So the bottom derivative is 2 cos 2x minus 6. Substitute in x equals 3 again. So x equals 3 is 2 times 3 is 6, minus 6 is 0, so it's 2 cos of 0. What is the cos of 0? The cos of 0 is 1. What are we left with? Negative 8 divided by 2, which is negative 4. Okay, so your final answer for this one is negative 4. Okay, so that would mean that there is a point discontinuity at x equals 3 having a y value of negative 4. Right, and that's it. That's video 4 actually of the series.